Welcome back to Physics from KSSM. So we are going to continue our chapter 4 heat on topic 4.3 specific latent heat. Let's get started. Okay, what is the meaning of latent heat? Latent heat, also known as hidden heat. So this topic will discuss about change of phase or change of state. The term change of phase means same thing as the term of state, change of state. For example, solid change to liquid, then liquid change to gas when we add heat to the substance. Okay, the meaning of the latent heat. Latent heat is the amount of heat required to change phase of substance without change in temperature. No increase in temperature or constant temperature. So the process involved here, we have process of change of phase, for example, melting process, solid change to liquid, freezing process, liquid change to solid, boiling process, liquid change to gas, and condensation process, gas change to liquid. So the amount of heat that required, we call it latent heat. Okay. So now we have specific latent heat. Specific latent heat, we use small l of a substance is a quantity of heat Q that is absorbed or released during change of phase of 1 kg substance without any change in its temperature. So from here we can write down a formula. An object of mass m absorbs a quantity of heat Q during change of phase. Therefore, specific latent heat of substance is L equivalent to Q divided by m, amount of heat per 1 kg mass. So we have L equivalent to Q divided by m. So from here, SI unit for specific latent heat is joule kg to the power -1. And from here formula, we can produce amount of heat required Q equivalent to ml. Okay, now because we have many processes involved in the change of phase, so we have melting and freezing, for example, or boiling and condensation. So we have a special name given for the latent heat involved. So a specific latent heat of fusion, LF, of a substance is quantity of heat Q that is absorbed during melting, or the quantity of heat released during freezing of 1 kg of substance without any change in temperature. So this one is for process of melting and freezing. So the name of the heat is latent heat of fusion. Specific latent heat of vaporization, LV, of a substance is quantity of heat Q that is absorbed during boiling, or the quantity of heat released during condensation of 1 kg substance without any change in temperature. So for the boiling and condensation process, the name of the heat is latent heat of vaporization. Okay, now when we discuss about change of phase, last time in 4.2 we have discussed about heat capacity, you still remember. So now we are going to apply when we discuss heating curve. Heating curve is a process where we supply heat and cause the temperature to increase, and then change of phase also occur. Now look at this one. At point P, the state of matter is solid. So PQ is solid state. So the heat is absorbed by solid to increase its temperature, or kinetic energy of molecule increases. So for PQ, you can see there is change in temperature. There's no change in phase. So the name of the heat required here, we call it heat capacity. You will still remember the formula that we discussed in 4.2, Q equivalent to mc delta theta. And then for QR, Q is melting point, as you can see here. It's already reached melting point. So Q is in solid state. Now Q to R, solid start to change to liquid, melting process. So QR, solid is melting. So latent heat is absorbed to weaken the bond between the molecules. Molecules are released from their fixed position and move throughout the liquid. Kinetic energy does not increase, or we can say constant temperature. So you can see there's no increase in temperature. There's only change of phase. So the name of the heat required here, we call it latent heat of fusion. Okay, now we look at RS. RS, liquid is heated until boiling point. There's no change in phase, but you can see here temperature increase. So the amount of heat required here, we call it heat capacity. Okay, so temperature increases, kinetic energy increases. And then when reach T, liquid state, now ST is boiling point. So meaning the liquid start to change to gas. So amount of heat required here, we call it latent heat of vaporization. Okay, so ST is the mixture of liquid and gas. Okay, so at T, all liquid change to gas. So T meaning gas state. So for TU, you can see there's increase in temperature. So meaning heat absorbed to increase the kinetic energy of molecule. So TU, you can see here TU, gas heated, heat absorbed, temperature increases, kinetic energy of molecule increases. So amount of heat required, we call it heat capacity. So you must be able to identify type of heat that required for each of this part and able to state the phase of matter at this all these parts for this heating curve. Okay, now this one is cooling curve, meaning the object start to cool down. From P is gas state. So PQ, gas cools to boiling point. Heat release, temperature decrease. Kinetic energy decrease. So amount of heat that release here, we call it heat capacity. Okay, so at Q, reach boiling point. So here, gas start to condense to become liquid. So QR, gas is condensing. So latent heat is released, molecular bond is formed, molecules move throughout the liquid, kinetic energy of molecules does not decrease, so constant temperature. Okay, so here you can see for QR, there's a condensing, the gas condensing, so amount of heat that released, we call it latent heat of vaporization. So when reach here R, all gas condensed to liquid already. So RS is in liquid state. So you can see there's a decrease in temperature. So RS here, liquid cools to freezing point, heat release, temperature decrease, kinetic energy decrease. So amount of heat release here, we call it heat capacity. Okay, so S and T is freezing point, meaning liquid start to freeze to become solid. So ST here, liquid is freezing, latent heat is released so that bond between molecule is strengthened, molecule vibrate around a fixed position, kinetic energy of molecules does not increase, so constant temperature. So the amount of heat released here, we call it latent heat of fusion. Okay, and then for case of TU, solid state, so heat is released, temperature decrease, kinetic energy decrease. So amount of heat that released, we call it heat capacity. So same thing as the heating curve, you must be able to identify the type of heat that's applied, whether it is a heat capacity or latent heat. And then you must be able to state state of matter for each of these parts. Okay, now let's look at activity 4.6. You can refer to your textbook. So activity 4.6, the aim for this activity is to compare and discuss specific latent heat of fusion of ice and wax, specific latent heat of vaporization of water and oil. The oil here, we discuss petrol. So you can refer to the value given here to answer the question given. For example, wax, specific latent heat of fusion. If you compare to ice, okay, the value of LF for wax is smaller than ice. And then you compare water and petrol, for example, specific latent heat of vaporization for water is much bigger compared to petrol. Okay, let's look at the question. Okay, 1A. Compare the specific latent heat of fusion for ice and wax. So just look at the value, then you write down the compare statement. Specific latent heat of fusion for ice is larger than that of wax. State the difference between ice and wax in terms of strength of bond between molecules. So strength of bond between molecule of ice is greater than that of wax. Thus, ice requires more heat to overcome the bond between molecules during melting process. For a specific substance, why is specific latent heat of vaporization larger than specific latent heat of fusion? So during boiling, amount of latent heat required is to break the bonds between molecules of solid and to do work against the atmospheric pressure when liquid change to gas. So meaning for the boiling, there are more latent heat required because there's an extra work done to go to do work against the atmospheric pressure. So during melting, amount of heat is just required to overcome the bond between molecule or solid when solid change to liquid. That's the reason why specific latent heat of vaporization is larger than specific latent heat of fusion. So the average kinetic energy of molecules does not increase, or we can say temperature is constant. Number 2, compare the specific latent heat of vaporization of water and petrol. So same thing, you just compare the value. Specific latent heat of vaporization for water is larger than that of petrol. Then state the difference between water and petrol in terms of strength of bond between molecules. So the strength of bond between molecules of water is stronger than that of petrol. State the difference between distance of separation between molecule in gaseous phase for water and petrol. The distance of separation between molecule in gaseous phase for water should be shorter than that of petrol. Water is denser than petrol because the bond is quite stronger compared to petrol. Okay, so you can just make correction for this one. Experiment 4.3, to determine specific latent heat of fusion of ice LF, determine specific latent heat of vaporization of water LV. But A, specific latent heat of fusion of ice LF, apparatus, immersion heater, filter funnel, beaker, electronic balance, power supply, stopwatch and retort stand. Okay, material, crushed ice. Place the beaker for the experiment set and the control set on the electronic balance respectively. Reset the reading of both electronic balances to 0. Set up the apparatus as shown in figure 4.16. Initially, both beakers and electronic balances are not below their respective filter funnels. Okay, so this is the control set, meaning the not connected the power supply. We don't on the power supply. Okay, and this one we on the power supply, the experiment set. Why we set this control set is to determine amount of the ice that melts due to surrounding temperature. Because in our calculation, we just calculate that the heat supply is by power supply, PT. So we just use the amount, we want to determine the amount of the ice that melts due to the electrical energy supply only. That's the reason why we need to set this control set. Okay, switch on the immersion heater for the experiment set only. When water is dripping out of the filter funnel at a fixed rate, place the beakers and electronic balances respectively below the filter funnel. Start the stopwatch. After time t equals to 10 minutes, record the reading of mass of water collected in the beaker or experiment set M1 and control set M2. Switch off the immersion heater and record the power of the heater P. Okay, now mass of the water collected in beaker, experiment set M1, mass of water collected in beaker or control set M2. Power of heater P, heating time T. So now we want to calculate mass of water collected due to the electrical energy supply only. So meaning we need to minus M1 minus M2. So thus we can calculate specific latent heat of fusion of ice using formula L equivalent to Q equivalent to PT. So PT divided by M1 minus M2. So we get the value of specific latent heat of fusion of ice. Part B, specific latent heat of vaporization of water, LV. Apparatus, high power immersion heater, 500 watt. Power supply, beaker, electronic balance, and stopwatch, water and tissue paper. Procedure: set up the apparatus as shown, switch on the immersion heater and wait until the water boils. When the water boils, start the stopwatch at the same time, record the reading on the electronic balance M1. After T 5 minutes, record the reading of electronic balance M2. Switch off the immersion heater and record the power of heater P. So you can hear. So we record initial reading of electronic balance M1, final reading of electronic balance M2. Time taken T, power of heater P. Then we can calculate specific latent heat of vaporization using the formula L equivalent to PT divided by M1 minus M2. M1 minus M2 is the mass of the liquid that changed to steam. Okay. So why does a control set need to be prepared for experiment A but not experiment B? For experiment B does not need a control experiment because there is no mass of water that changed to steam due to surrounding temperature. As we know, surrounding temperature will never reach boiling point of water. So surrounding temperature does not cause the liquid to change to steam or gas. Number 2, given specific latent heat of fusion. Here, compare the value of specific latent heat of fusion obtained from experiment and the value given. Explain the difference between the two values, if any. So number 2 and 3 are the same. The question is quite the same, so I think the reason is quite the same. So the value of specific latent heat of fusion from experiment A is higher than the given value because part of heat supply is lost to surroundings. The loss of heat causes the value of mass is lower than expected value. Thus, from this formula, we can see when mass is lower, it will cause the value of L become larger. That's the reason why in experiment we get higher value of L for LF. Okay, number 4, suggest ways to increase accuracy of result of this experiment. This one should be number 4. The beaker must wrap with cloth or heat insulator to reduce heat loss to surrounding. The heater must be fully immersed in water to reduce direct heat loss to surrounding. So you can go and search in the internet for more information on this topic. Okay, now about change of phase of water. So when ice melts, ice molecule absorb latent heat of fusion, causing ice to change from solid to liquid. No change in temperature, melting point. When water boils, the water molecule absorb latent heat of vaporization, causing water to change from liquid to gas. When water vapor condenses, the water vapor molecules release latent heat of vaporization, causing water vapor to change from gas to liquid. So this is one example that shows how a change of phase of water occur. Activity 4.7, this one to show evaporation causes cooling. Apparatus 250 ml beaker, drinking straw and white tile, material, alcohol and water. Instruction set up as here. Pour 100 ml alcohol into beaker. Touch the outside beaker and water around the base of the beaker. Record your observation. So before you start the activity, you record the situation of the beaker. Blow air repeatedly into the alcohol. Touch the outside beaker. Record your observation. Okay, now we want to discuss what exactly happened. What happens to the alcohol when air is blown into it? So you can see the alcohol, the boiling point is very low. So this one will cause the alcohol to evaporate and change to gas. Number 2, compare the level of coldness of beaker before and after air is blown. Explain your answer. The beaker is colder after air is blown because molecules of alcohol will absorb heat from the beaker or surroundings in order to evaporate. State the effect of evaporation. Evaporation will give effect of cooling or evaporation cooling. So you can see the beaker become cold, or the surface become cold when you blow using the straw towards alcohol, causes the alcohol to evaporate. Okay, so generally we can say specific latent heat of vaporization is required in the change of phase from liquid to gas. This heat is absorbed from the surrounding. When a liquid evaporates, the liquid molecules absorb this heat to break the bond between molecules. The surrounding loses heat, therefore evaporation causes cooling to the surrounding. Okay, application of specific latent heat in daily life. We have steaming food, steam food. Specific latent heat of vaporization of water is large. Plates filled with food are able to absorb heat from the hot steam. The condensation of steam at the base of the plate releases large quantity of heat and thus enables food such as cake, fish, eggs and others to be steamed. So the condensation of process release large amount of heat that able to cook food. Evaporation of sweat, sweating. We sweat on hot days while doing heavy works. When sweat evaporates, heat is absorbed from the body, causes a cooling effect. The rate of evaporation will increase when there is air circulation. So DIY, wet your right hand, put your right hand which is wet and your left hand which is dry in front of the table fan. What the difference you can feel on your right and left hands. Try and see. Okay, cooling system in refrigerator. A refrigerator uses cooling effect from evaporation. During circulation of cooling agent, heat is absorbed from inside the refrigerator and released outside. Okay, compressor number one. Compressor compresses cooling agent gas to increase pressure and its temperature. We have a cooling agent in the refrigerator. So next what happened? In the condenser, the cooling agent releases latent heat during condensation. Cooling agent flows through expansion valve, and here in the evaporator, cooling agent evaporates and absorbs latent heat from the inside the refrigerator, so heat absorbed. So the cooling agent flows out from the evaporator to the compressor and the process repeated. So you can see the evaporation in the freezer will produce cooling effect in the freezer. Okay. So we have the calculation problem. Let's say look at example 1. Figure 4.22 shows a 480 watt immersion heater used to melt ice in container in 120 seconds. The reading of electronic balance decreases by 0.172 kilogram. A. What is the mass of ice that has melted during the heating period? Calculate specific latent heat of fusion of ice. Okay, list out all the information. Mass, mass of the ice melt to become liquid. So it's 0.172 kilogram. So P equals to 480 watt, T equals to 120 seconds. So PT equivalent to MLF. Actually, it's Q equals to ML. The heat supply is PT. So from here, we want to calculate what is LF. So LF equivalent to 480 times 120 divided by 0.172. So we get 3.35 times 10 to the power 5 joule kg negative 1. Okay, second example, what is amount of heat supplied by water heater to change 0.75 kg water at 30 degrees Celsius to steam at 100 degrees Celsius. State the assumption you make in your calculation. So given specific heat capacity of water, specific latent heat of vaporization of water. Okay, now in this case, there are two types of heat involved, heat capacity and latent heat. As you can see here, from 30 degrees to 100 degrees Celsius, there is change in temperature. So meaning 0.75 kilogram of water at 30 degrees Celsius absorb heat or heat capacity. So we mark as Q1. So Q1 equivalent to MC delta theta. So there is an increase in temperature from 30 to 100. And then 100 degrees Celsius is boiling point. So here, heat is absorbed to change water to steam. So the heat involved here is latent heat of vaporization. So there are two types of heat involved here. So the total energy or the amount of heat supply is equivalent to Q1 plus Q2. Okay, assumption made, all heat supplied by heater absorbed by water. No loss of heat to surrounding during heating and change of phase. There are two stages of change. Increase in water temperature here, okay, 30 to 100. Change of phase here, water to steam without change in temperature. So what we do, we just total up Q1 plus Q2. So Q1 MC delta theta plus ML. So we substitute all the values. So then we get amount of heat supply is 1.9210 times 10 to the power 6 joule. So normally the calculation problem, they combine heat capacity and latent heat. So you must be able to differentiate between the heat capacity and latent heat. Just remember that for heat capacity, there must be change in temperature, no change in phase. But for latent heat, there's no change in temperature, but there is change in phase. Okay. So that's all for this topic. So just subscribe, like, and tag for more oncoming videos. Support physics teacher.